Hi, welcome. My name is Prosper Nwangu, and today we're going to be looking at the topic sulfur. Now, sulfur as a topic is going to span for 2 weeks. For the first, we're going to look at basic features of sulfur, which include the physical properties, chemical properties. We're going to look at the amorphous forms of sulfur and the crystalline forms of sulfur. We're going to look at the extraction of sulfur. While for next week 2, we're going to look at compounds of sulfur, which include hydrogen sulfide, sulfuric acid, and salts of sulfur. Let's proceed. Specific objectives for this lesson is, at the end of the day, you should be able to describe sulfur. In regards to description of sulfur, we talk about the group. You should tell me what group sulfur belongs to, the period it belongs to, its color, its symbol, atomic number, electron configuration, oxidation number, and the rest of it. Next, you should be able to explain, describe the Frasch process. The Frasch process is the process of extracting sulfur. And lastly, you should be able to state and explain the allotopes of sulfur. Allotopes of sulfur is categorized into 2 forms: the crystalline allotopes of sulfur and the amorphous allotopes of sulfur. Now, sulfur as an element, sulfur has the symbol S and has an atomic number of 16. It makes up about 0.1% of the Earth's crust and can be found in USA, Japan as sulfides of iron, zinc, and the rest of them. So it is usually bright yellow and has the chemical formula S8, is polyatomic. The elemental sulfur is crystalline at room temperature. Electronic configuration of sulfur. Now, in our video we have 3 forms of this electron configuration. Now, the first form is of the Hund's rule. This next one is of the Albauer principle. It is important to know the electron configuration of every element. Remember that it is not something to be crammed, it's something to be practiced. So you take each element and write down the electron configuration. Now, this is important for answering most wire questions, especially objective aspects. These could be bonus questions because they are very simple to answer. And the last aspect we have is the condensed form of the Albauer principle for representing the electron configuration of elements. For the oxidation number of sulfur, we are most conversant with the oxidation number of -2 and of the oxidation number of +6. Other oxidation number includes 0, +2, +8. Now, every element in its form standing alone has the oxidation number of 0. Now, sulfur can exist as +2 in the thiosulfates, and it can exist as +4 in trioxosulfates. The Frasch process. Now, in the Frasch process explores 2 major physical properties of sulfur. The first property is the solubility of sulfur. Sulfur is insoluble in water but soluble in methylbenzene, which is also referred to as toluene, and also soluble in carbon 4 sulfide but not in water. The next property of sulfur is its melting point. The Frasch process also explores the melting point of sulfur. Sulfur melts at 119 degrees Celsius, while the Frasch process uses a superheated water of about 170 degrees Celsius to extract sulfur. So how is this done? Now, in the video that's going to be coming up next, we're going to be looking at this in details, but briefly let me tell you how this happens. Now, sulfur exists in underground deposit, so concentric pipes is inserted into this deposit. In the outermost pipe, sulfur or superheated water is forced into the underground deposit. This melts the sulfur deposit. Now, from the middle concentric pipe is forced air at about 5 atm. Now, this air forces the melted sulfur through the middle pipe. Now, in the next video, you're going to see more explanation on this. So, from our diagram, we have the outermost pipe having the superheated water at about 170 degrees Celsius forced into the sulfur deposit, which is beneath there. And then from the middle, we have air of about 5 atm forced through the middle concentric pipe. Now, this hot compressed air forces sulfur to go through the middle pipe and is collected as seen in the video.
Frasch process for extraction of sulphur. The fresh process is based on the fact that sulphur has a comparatively low melting point. The fresh pump, consisting of 3 concentric pipes, is sunk deep into the sulphur bed. Superheated water at about 170 degrees Celsius under pressure is pumped into the outermost pipe. The superheated water enters the sulphur bed. This melts the sulphur present in the sulphur bed. Compressed air under a pressure of about 20 to 25 atmospheres is pumped in through the innermost pipe. This forces the mixture of water and molten sulphur to gush out of the middle pipe. This mixture of molten sulphur and water is collected. On cooling, about 99% pure sulphur gets separated.
Hello, welcome back. Hope you enjoyed the video on the extraction of sulfur by the fresh process. Next, we're going to be looking at the allotopes of sulfur. Sulfur can exist in 2 forms: the crystalline allotopes of sulfur and the amorphous allotopes of sulfur. Remember that carbon also exists in crystalline form and in amorphous form. Crystalline forms of carbon include graphite and diamond, whereas the amorphous forms of carbon include coal, charcoal, and the rest of it. For the crystalline allotopes of sulfur, we have rhombic sulfur. Rhombic sulfur is the first crystalline allotope of sulfur that exists at room temperature. It is also known as the alpha sulfur. And next, we'll also look at monoclinic sulfur. It's also part of the crystalline allotopes of sulfur. It is also known as prismatic or beta sulfur. Now, as under the amorphous forms of carbon, we have the amorphous sulfur. It is also known as the sigma sulfur. And lastly, under amorphous form of sulfur, we have plastic sulfur. This is not really a true allotope of sulfur. We're going to see reasons for this. Now, the rhombic sulfur. The rhombic sulfur, remember I told you, is part of the crystalline form of sulfur. It is designated with alpha, or referred to as alpha sulfur. It is stable at temperatures below room temperature, or at room temperature you can have rhombic sulfur. Every sulfur at room temperature is referred to as rhombic sulfur. It is bright yellow in color. It has an octahedral shape. It has a melting point of 113 degrees Celsius, and it is stable under 96 degrees Celsius, which is way above room temperature. As for monoclinic sulfur, is also a crystalline allotope of sulfur, but in this case, it's a sulfur that exists at temperature above 76 degrees Celsius. When you take rhombic sulfur and heat it to a temperature above 96 degrees Celsius, you have monoclinic sulfur. Now, when this sulfur is allowed to stand, it will revert back to rhombic sulfur at temperatures below 76 degrees Celsius. It is amber in color. It has a needle shape. It has a melting point of 119 degrees Celsius, and it is stable between 96 degrees Celsius and 119 degrees Celsius. Now, from the diagram, you see that above 96 degrees Celsius, rhombic sulfur becomes monoclinic sulfur, and then when it cools down to temperature below 96 degrees Celsius, rhombic sulfur is formed. So this temperature at which rhombic sulfur and monoclinic sulfur tend to form is called the transition temperature. Please look up more on transition temperature. Amorphous allotopes of sulfur. Now, I told you there are 2 amorphous forms of sulfur. We have the amorphous sulfur and we have the plastic sulfur. My favorite is the plastic sulfur. The whole preparation process just tends to be interesting. Let us start with the amorphous sulfur. Now, from what we have in the video, amorphous sulfur is prepared as a pale yellow, almost white deposit when hydrogen sulfide is bubbled through water for a long time and the saturated solution is exposed to air. Now, that is how we prepare amorphous form of sulfur. Probably in subsequent practical classes, we're going to see videos on the preparation of amorphous sulfur. Now, for for the plastic sulphur is prepared when solid sulphur is heated and melts. The resultant liquid is poured into a beaker of cold water. The substance formed is plastic sulphur. This plastic sulphur is elastic and feels like rubber. Our assignment. Now, your assignment for this lesson, all the assignment and classwork is only going to be found, that is accessed in the Google Classroom. So for those that have not joined the Google Classroom, you can join the Google Classroom with the code YEE4C5D. Now note that if you join this classroom with names that is not recognized by the school management, you will be removed from the classroom. So what I recommend you do is you go to your settings and change the name for your account to your official name, a name that is recognized by the school and not a made-up name. So all notes, assignment and classwork will only be accessed in the Google Classroom. It will be submitted in the Google Classroom. Under no conditions should an assignment or a class activity be sent to my mail or my WhatsApp contact. Thank you for watching. Do have a nice day and stay safe.